right, welcome to our lesson on solving equations that have like terms. So let's just refresh our memory on what like terms are. They are terms that have the same variable, like x's, y's, z's, and they have to be raised to the same power. So they have to have the same exponent if they have one. Now, constants are also like terms. And constants are numbers that don't have variables, so just plain numbers, positives or negatives. All right, what I suggest is that we circle the like terms, but they have to be on the same side of the equal sign. Then you're going to either add them or subtract them. And you're going to use whatever sign is in front of the term, and I'll show you what that means in a second. Then you're just going to solve the equation using inverse operations. All right, let's start with our first example. We have 4x plus 7 plus 2x equals 43. So for this one, our like terms are all on the left side of the equation. We have 4x, so I'm going to circle that one, and plus 2x. Now notice I put the plus in my circle because that tells me how I need to combine them. So in my thought bubble, I'm thinking 4x plus, because there's a plus right here, 2x. Okay, so 4x plus 2x gives me 6x. So now I've simplified my equation, and now it is 6x plus 7 equals 43. Okay, so remember we use the box method, or I like to use the box method. So I box the term that is by itself. 43 is the only thing on the right side of the equation. So I know I cannot move that. I'm going to move the 7 into the box using inverse operations. So I've got plus 7. So the inverse would be to subtract 7. I'm going to write it under the 7 and in the box. Now the plus 7 and the minus 7 give me a 0 pair. Okay, so I bring down my 6x, and then I do 43 subtract 7. I calculate that and I get 36. So now I've got 6x equals 36. 6x is multiplication, and the inverse of multiplication is division. Okay, and the little rhyme that I teach to kind of remember that is the 6 and the x are side by side. When they're side by side, you need to divide. So I'm going to divide by 6 here and here, and I actually need to box this side. All right, 6 divided by 6 gives me 1x, which is just x. And then I calculate my box. 36 divided by 6 is 6. So I'm saying that my answer is x equals 6. Now I want to check that answer. So I take my original equation, like this, and I take out the x's and I put in parentheses. That's going to help me remember that I need to multiply. So everywhere where there was an x, I'm going to put a 6. Then I use I use order of operations. All right, so 4 times 6 is 24 plus 7, and then 2 times 6 is positive 12. And then I just add those up. 24 plus 7 is 31. And 31 plus 12 gives me 43. And since that matches the other side of the equation, I know I got it right. All right, let's try another example. All right, so this one, there's several things going on that left side of the equation. I'm going to leave the equals 12 by itself. I'm just going to go ahead and I've already brought that down actually. All right, so on this equation, I've got two sets of like terms. I've got x's, and I'm going to circle the sign that's in front of those coefficients so I know how to combine them. So plus 7x, I think of that as just positive 7x. And then I'm going to subtract, because I have a minus right there, 9x. And 7x minus 9x gives me negative 2x. Okay, I've also got constants. I've got 12 subtract 4. So in my thought bubble, I'm going to subtract 12 and 4, and that gives me a positive 8. So I haven't actually solved anything for this equation, but I have simplified it to negative 2x plus 8 equals 12. I'm going to put my box around the 12, and then I'm going to move my 8. So I've got plus 8, so the inverse would be minus 8. Again, plus 8 and minus 8 give me a 0 pair. So from the left side of the equation, I'm going to bring down my negative 2x. And then I'm going to calculate that box. 12 minus 8 gives me 4. All right, negative 2 and x are side by side, so I need to divide. And when I divide, I have to divide by the exact coefficient of x. I cannot change my sign or anything like that. So I'll be dividing by negative 2. So this gives me 1x. And then 4 divided by negative 2 is negative 2. So my answer is x equals negative 2. All right, we're going to check that answer. So we start with our original equation. Everywhere where there was an x, I'm going to put a negative 2. And again, have to use order of operations. So we're going to multiply first. So 12. Now when I multiply this, I'm thinking positive 7 times negative 2, which is negative 14. So I'm actually going to write 12 minus 14. That sign just kind of takes over. Then bring down your minus 4. Then when I multiply this next one, I'm thinking negative 9 times negative 2, which is positive 18. All right, we'll calculate that. 12 minus 14 is negative 2. We'll just go one step at a time. Negative 2 minus 4 is negative 6. And then negative 6 plus 18 is 12. So it matches. So I know I got that answer correct. All right, our last example is a word problem. We're going to write an equation and we're going to solve it. So let's see what we've got. Molly visits the concession stand at the baseball game and buys 2 suckers and a $4.50 order of nachos. Later, she goes back and purchases 3 more suckers. She spends a total of $8.25. How much does 1 sucker cost? So the first thing we're going to write down is what's my variable and what does it represent? So I'm going to use an S. If you'd rather use an X, you can. But I'm going to use an S, and an S stands for suckers. That just helps me remember what I'm talking about. All right, now I'm going to go back through and I'm going to reread my equation. So the first thing she buys is 2 suckers. So that would be like 2S. Then she bought that $4.50 order of nachos. So plus $4.50. And then later she went back and she purchased 3 more suckers. So that's 3S. And then it says that was a total. Total is where we put the equal sign of $8.25. Okay, now it's time to solve the equation that we just wrote. Again, we've got some like terms. She bought 2 suckers and then 3 suckers. So that's a total of 5 suckers. Okay, plus the nachos that were $4.50, and her total is still $8.25. Okay, so to solve this, I'm going to box the $8.25, and I'm going to subtract $4.50. Okay, gives me a 0 pair here. So I have 5S equals, when you subtract $8.25 and $4.50, you get $3.75. Okay, and then we would need to divide by 5. So that gives us 75 cents per sucker. So 1 sucker cost 75 cents. And that concludes our lesson.